Hello, welcome to this webcast from Enea Software. My name is Nigel Day and I'm Product Manager for Polyhedra, Enea's family of database management products. This webcast is the third and final one on the topic of active queries, which is one of the features of Polyhedra that makes it particularly suited for use in embedded systems. The first webcast introduced the Polyhedra product line, explains why traditional techniques do not properly address the needs of systems where a real-time database has to handle multiple clients that have to detect and react to database changes as fast as possible. The second part described features of our active query mechanisms that keep clients up to date with minimal complexity, low latency, and low load on the database management service. In this final part, I'll give a live demo of active queries in action and show how simple it is to write a client application that uses an active query. To start off the database, I shall issue a simple command line command. And because I used the start parameter there, it is done as a separate background process. I shall now start off a second client which I can use for typing in raw SQL at the database. Using this client, I can launch queries, and these queries can be general on the whole table as this one was, or I could hone into individual records or individual fields of records. I should now go back to my original command line shell and start off a particular client which is supplied in the evaluation kits and release kits in both source code form and as an executable, which illustrates active queries in action. Rather boringly, is called active. And it connects into the database and shows the results of the query, which in this case shows the contents of the same table as I queried above. Now if I go up to this if I go up to this window here and make a change and hold, excuse me for a moment if I go quiet while I make the change. And when I hit the return after typing commit, the order to do the change is sent through from the client to the database. And we see in this window here that the active query client has immediately been notified about the change and shows the changed value of the field. If I come back up to this window and issue the command again, we can again see that the active query client is responding to this change. The final thing I want to do before going into looking at the code in detail is just to shut down the database. Now both clients realize that the database server has stopped and therefore they terminate. We're now in a position to look at the code that underlies the active queries launched by the client application. Normally when you're just launching an active query, a normal query, non-active, then in ODBC you allocate a statement handle and then you use this statement handle to specify the query you want to launch. Once SQL exec direct returns control to the application code, we can then go on and inspect the result set. In this case, we have a function written here, fetch all data, which will print out the contents of the result set. The next stage is to make this query an active query. And actually it's very simple. We just have to set a flag on the statement handle to say that you want a dynamic cursor rather than a static cursor. And the Polyhedra client library code interprets this as a request for a active query rather than a static one-shot query. The final thing that needs to be done before launching the query is to enable events. And this will allow us to unpick the deltas whenever they are received. And here we're using a standard ODBC function, setStatementAttr, but we're using a Polyhedra specific attribute for this statement handle, and what we're doing is enabling events on the statement. So now we've launched the query and processed the initial result set. We now go on to the main loop, which will be handling events. Having launched the active query and processed the initial result sets, we're now in position to have a look at the main loop, which will handle events. Let's build this up gradually. There will be a for loop. Inside that for loop, we will be calling an inner loop which will process all the outstanding events. And we use a Polyhedra specific function for doing this, getAsyncEvent, with a parameter pointing at the environment handle saying we're interested in global type events. At the very end of the loop, after doing all the processing, which I shall get to in a moment, we wait until more events are generated. So most of the time one hopes that the application will be sitting in this function waiting to be told to continue. Let's move on to the inner loop. And what we're going to do here is switch on the function type which identifies what type of event has been received. In this application we're only expecting two different types of event. One is a disconnect event, which indicates that the database service has been stopped or the connection to it has been lost. And the second case is SQL fetch a delta. So in the first case we just simply exit out of this routine. In the second case we shall do what processing is needed for the delta and then go around to the next event. What processing is needed? Well, because we've enabled events on the statement itself, we can call this function here SQL getAsync statement event, and this will return a pointer to every row in the result set that has been affected by the delta. By affected I mean inserted, deleted or updated. In the case of an insert, all the values will be available. In the case of an update, this fetch by bookmark function will be able to detect which fields have been changed for this record. In the case of a deletion, the ODBC library on your behalf will have cached the previous reported state of the record, and you'll be able to access this inside that bookmark function, and therefore you'll be able to tidy up as the record disappears. In this particular application it will just be a question of reporting the record has been deleted. So there's no need to iterate over the whole result set. This function, this event mechanism, will make sure that you're only looking at the records that have been altered by the delta. And basically that's the complete code of this application. Obviously, I've left out all error handling, and I've left out the definition of functions such as fetch by bookmark and the earlier function to print the initial result set. But to produce an active query application from an application which is just doing a simple standard one-shot query is simply a question of enabling the query as an active query, enabling events on that query, and then doing a for loop which will detect events as they come along. So, in summary, why use active queries? Basically, they give you the performance you need. There is no polling, and the latency is very low, and the load on the server is very low indeed. Also, there's much less network traffic because there are not the constant query load going through from client to server that would be needed if the client was doing continuous polling. As a result, the overall scalability of the system is improved, and should the system start misbehaving, then you get a much better degradation of performance. It's much more gradual rather than catastrophic. I haven't mentioned in this part of the talk, but it's also possible to use active queries for pushing in through updates with an optimistic concurrency control mechanism, so active queries are very powerful. What I have shown in this part of the webcast, though, is that active queries are very easy to use. It avoids the needs for any separate publish and subscribe mechanism, and there's no need for special database trigger code to be managed by the people writing the application or the database administrator. So performance, power, and simplicity together make a triple punch, which make active queries the good solution for making sure that clients can keep up to date with what is happening in the database. That ends this webcast, in fact ends this series of webcasts. If you want more information about Polyhedra, or if you want to download white papers or evaluation kits, please visit one of our websites. Thank you for listening. I hope you found it interesting and useful.